Hey everyone, and welcome to Quadratic Functions Part 2. Today we're going to go through two examples of common questions that you might see when you're dealing with quadratic functions. Remember, I can't show you absolutely everything, and it can only give you a sample of some of the types of things that you will see. So the first question for today is an error question. It says find the error in the calculation. And the question was determine the roots of the quadratic function given by this. And this is what the student answered. So this function right here is a quadratic equation. They've given it to you in factored form with the two x-intercepts in the brackets. And they said that the whole thing is equal to 6. So this person took the two factors, said x minus 2 has to equal 6, x plus 3 has to equal 6, added 2 to both sides to get 8, and here they subtracted 3 from both sides to get 3. So at first glance, it doesn't look like the student has done anything wrong. The math itself, the rearranging of the equations and the setup is right. The problem is this 6 right there. If you're trying to solve a quadratic equation, which means if you're finding the roots, you're solving, or you're finding the x-intercepts, those all mean the same thing. And when you're doing that, you have to have the whole thing equal to 0. This will not work if it's not equal to 0. The only reason it works when it's equal to 0 is because 0 times this equals 0, and this times 0 equals 0. So if this equals 0 or this equals 0. But there's many ways that you can have something equal to 6. So this only works if it's equal to 0. So you need to keep that in mind and watch for that. So even though the solving looked okay, this was the problem. So what needed to happen first is you needed to move the 6 over and set it equal to 0. Then you have to work out the brackets and simplify. And you need to find two numbers that multiply to give you negative 12 and add up to give you 1. So that would be 4 threes. So x plus 4 and x minus 3. And if you're not sure if it works, test it out. Minus 3x plus 4x is going to give me positive 1x. 4 times 3 is 12. Positive negative is negative. So then I can set these two pieces equal to 0 and solve. So x is equal to negative 4 or x is equal to 3. You could have also used the quadratic formula from this point right here, minus b plus or minus the square root of b squared minus 4ac over 2a. You could have used that at that point as well, and you would have still ended up with minus 4 and 3 as your answer. Okay, the second question that we're going to look at today is a word problem. And it's a word problem where they've given you the equation. In part one, we looked at one where you had to come up with the equation yourself. So for this one, they've given you the equation that you're using, and they're asking you some questions about that equation. So in part A, I guess first maybe we should read the question. So we've got a cannon being fired from the top of a cliff. So I'm going to draw a quick picture of it right here. So we're firing a cannon off the top of a cliff into the water. It says the height of the cannon above the water is given by this equation, where x is the horizontal distance, so the distance away from the cliff. And the first question is, what is the initial height of the cannonball? If you see the word initial in a question, they're looking for the y-intercept. And the y-intercept is your c value. So A, B, C. So the initial height of your cannonball is 100 meters. So that cliff is 100 meters tall, is where you started. How far from the base of cliff is the height of the cannonball at its maximum? If you see the word maximum anywhere or minimum, you're looking for the vertex. And for the vertex, you're using x equals minus b over 2a to get the x coordinate, and then you're looking to plug it back in to get your y coordinate. So this is saying from the base of the cliff, how far out is it when it hits its maximum? So in other words, they're looking for the x coordinate of the vertex. So plug your numbers in. So minus 1 over 2 times negative 0.005, which gives you, when you work it out on your calculator, 100. So it's 100 meters out when it hits its maximum. What is the maximum height? Well, that's when you have to go back to your equation and plug it in. So for part C, I'm going to go h is negative 0.005 times x, which is 100, squared, plus x, which is 100, plus 100 more. So this is going to give you, when you work it out, 100 squared times 0.0005 negative, add 200 is going to give you 150 meters. So the maximum height of the cannonball is 150 meters. So I can go back up and put that in my picture. So my vertex is at 100 out and 150 meters high. So the last part of this question is that the cannonball was fired at an enemy boat. So we got a boat now sitting out here 300 meters from the cliff. Did the cannonball hit its intended target? And we have to explain. Part of the explaining process can be just showing your work to explain what it is. If the cannonball hits the boat's sitting on the water, we can assume that it's the x-intercept. To find x-intercepts, I'm looking for the roots of this equation. And when I have an equation that looks like this with a bunch of decimals in it, it's not going to be an easy job to use just basic factoring on that. So right away, I would go to the quadratic formula to find my x-intercepts. Minus b plus or minus the square root of b squared minus 4ac all over 2a. So minus 1 plus or minus 1 squared minus 4 times a, 0.005, times c, 100, extend my line out, all divided by 2 times negative 0.005. Scroll down so we can see it better. So x equals minus 1 plus or minus. If you work out what's inside that square root, this part here works out to be 2. So you've got 1 plus 2, because negative negative makes positive. So this ends up with the square root of 3 over negative 0.01. Then I divide it up into my two cases. The positive case, the adding part, minus 1 plus the root of 3 over that, gives me negative 73.2 for x. And if I do the negative 1, where negative 1 subtract square root 3, all divided by 0.1, I get 273.2 meters. Well, if you think about it, negative distance doesn't make sense in this case. We get a negative distance because the parabola is going to go backwards in time. So this one doesn't make sense. It's an extraneous root. Okay, a root that doesn't make sense is called extraneous. So the cannonball hit the water 273.2 meters out. The boat was 300 meters out, so the cannon did not hit the enemy boat. The cannon ball hit the water at 273.2 meters. And that is how you do word problems that may have a context involved and they're asking you some questions about an equation. So look for those keywords, and I'll go back up a minute. Once again, those keywords are initial. Initial means you're finding the y-intercept. If you see maximum or minimum, you're looking for the vertex. And if you see that something is sitting on the ground, like it's a golf tee or whatever, something is sitting on the ground, then you're looking for the x-intercept. Always drawing yourself a quick picture of what's going on to ask yourself if things make sense. This vertex that we found makes sense in this question. The point that it hits the water makes sense in this question because it's after 100. And it's always good to have that mental picture of what's going on so that you've got a good idea of what the situation is asking you. So hopefully that has helped with a few of the things that you're going to see with quadratic functions. And if you have any questions, please see me in the AC classroom at any time. Bye for now.